Now, for what we have in the case of the fourth problem, now it says to use the remainder theorem to find out p of negative 3 whenever p of x is equal to 2x cubed plus 4x squared plus 3. It says specifically give the quotient and the remainder for the associated division and the value of p of negative 3. And so we have with p of negative 3, you can see we have x equal to negative 3, and this would be in reference like to where we have the divisor to be at x plus 3. Now, in terms of taking what we have, say just from looking at it through the lens of line division, so it would have like negative 3 would be the 0 of the divisor, x plus 3. And taking into p of x, so I have 2x cubed plus 4x squared. If you notice, we have a missing first order x term. And we have closing out with the constant, which we have at 3. And again, in line with what we have with synthetic division. Okay, so again, we have negative 3. We have 2, 4, 0, and 3. And with synthetic division, bring down 2. Negative 3 times 2 is negative 6. 4 minus 6 is negative 2. Negative 3 times negative 2 is positive 6. 0 plus 6 is 6. Negative 3 times 6 is negative 18. 3 minus 18 is negative 15. So, for what we have in the result, okay, now we have for the remainder in p of negative 3 will be the same. I'll just stress this. Okay. And p of negative 3 as well as the remainder. Okay, we have equal to negative 15. And in terms of what we have with the quotient itself, okay, so we have 2 will be in reference to 2x squared. We have negative 2 will be in reference to negative 2x. And we have minus 6. Now, for what we have in the case of the last problem, it says you use the factor theorem to determine whether x minus 2 is a factor of the given polynomial expression. And it says specifically evaluate p at the proper value and then determine whether x minus 2 is a factor. So we're going to take what we have along the lines of synthetic division. Okay, so we have in this particular case, right? So we have x minus 2. Okay, and if I set x minus 2 to 0, I have that x is equal to 2. And we have setting up items along the lines of synthetic division. So I have 2. And with what we have from the dividend, so I have 2 for 2x to the 4th, negative 2 for minus 2x cubed, negative 4 for minus 4x squared. Now notice we do not have a first order x term. So I'm going to fill in 0. And then we have with 6. And we have, so in the lead off with synthetic division, bring down the leading coefficient 2. 2 times 2 is 4. Negative 2 plus 4 is 2. 2 times 2 is 4. Negative 4 plus 4 is 0. 2 times 0 is 0. 0 plus 0 is 0. 2 times 0 is 0. And we have, in this case, all right, we have the remainder is going to be at 6. And now, for what we have in this particular case, now we're going to have for the quotient, okay, now the quotient we would have at 2x cubed plus 2x squared. And again, your x term and your constant are negligible. Now, for the remainder is equal to p of 2 which in turn is equal to 6. Now, by the factor theorem, okay, since we have that the remainder, P of 2 is equal to 6, it is not equal to 0. If we had a 0 remainder, then the divisor would be a factor of the dividend. And it turns out that since it does not equal to 0, it's going to result that what we have here, x minus 2, is not a factor.